To contain a selenium atom.
2cc 4-methylselenium 2 5-dimethylselenium 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 2cc 4-methylselenium 5-dimethylselenium 4-methylselenium 2.
Welcome back.
They want you to think it's just chemistry.
The reaction says otherwise. It doesn't just dissolve matter, it erases the evidence.
The readout says Selenic, but the molecular signature is fluctuating. It's like the acid is trying to hide its own identity.
The mass spec is jumping all over the place. Why can't we get a lock?
It's eating the substrate. It's pulling moisture from the air, reacting with the lime in the concrete. The heat is causing it to off-gas selenium dioxide. If that reading hits 500 ppm, this room becomes a gas chamber. Mask up.
The spicy analog. If this gets out of the lab, we aren't just looking at a chemical spill. We're looking at a total erasure of the physical record. The liquid doesn't just corrode. It seems to seek out the most structurally sound points of an object first. We found the lead scientist's wedding ring at the bottom of the vat. Only the gold was gone. The band was perfectly intact. That is not science, that is a message.
Selenium, a non-metal. It has properties between that of sulfur and tellurium, with some arsenic. Its similarity with sulfur makes it interesting. Selenium takes place of sulfur in amino acids like cysteine and methionine. These fake amino acids form selenyl sulfide or diselenide bridges instead of the strong disulfide bonds that give nails their rigidity. For most sulfur compounds, you can simply swap out a sulfur for a selenium atom. Selenium analogues have a different personality. For example, the selenium analog of sulfuric acid, selenic acid, although less acidic, it is more oxidizing, and it can dissolve gold. Selenium is usually dissolved using nitric acid, but it can be dissolved using hot concentrated sulfuric acid. It is less stable in sulfuric acid. It is easily reduced and not so easily oxidized. It forms polyatomic cations that give interesting colors. You will often see a green solution at first, which turns yellow as it oxidizes further. For making selenium compounds, the most useful reagent to start with is either selenous acid, sodium selenite, or selenium dioxide. We first make selenium dioxide by dissolving selenium in red fuming nitric acid. This creates a lot of nitric oxide fumes, so you're best off not doing this or doing it in a well-ventilated area or in a fume hood. You want to have used the least amount of nitric acid as possible, because once you have dissolved your selenium, you need to purify it by removing the nitric acid. This is done by heating and evaporating, adding water, evaporating again, until you completely evaporate and you are left with a white solid. This is your crude selenium dioxide. This is further purified via sublimation. To make selenous acid, you just need to add distilled water or deionized water. To that, you add a stoichiometric amount of sodium hydroxide to get sodium selenite. You can test for this using silver nitrate. You will get a white precipitate. Sodium selenite is used to decolorize glass, neutralizing the green tint from iron impurity. In larger amounts, it turns glass various shades of pink or ruby red. Selenium dioxide is too volatile. You need time for the selenium to diffuse into the molten glass. Selenium dioxide is used for bluing steel. This was a die holder for cutting threads that I made myself. I used selenium dioxide, copper sulfate, and phosphoric acid. The phosphoric acid cleans and etches the surface. The iron in the workpiece reduces the selenium to elemental selenium, and you get copper selenide. Copper selenide, along with the ferric oxide, forms a film on the surface of the workpiece. When molten selenium is poured into water, you get these black biconcave discs.
Forbidden donut.
While selenium would just pass through you, selenium dioxide would be fatal if you had even 5 grams of it. It can make you very sick if you even inhale some of the dust. So while selenium is essential for thyroid function, there is a safe upper limit of 400 micrograms. So if you didn't know, you should never eat more than 6 Brazil nuts in one day. Heat causes sublimation and your product crystallizes on a cold surface. My beaker cracked due to thermal shock. Even heating is much better. This was good enough for my purposes, but don't follow this as an example. I was able to recover what looks like some pure product. At least it hasn't reduced back to selenium. To oxidize our solution of selenous acid, we're going to need something powerful. I'm going to use bromine for this. That pink color you can see is almost unavoidable. That is elemental selenium that has been reduced by something. Forensic chemists use selenous acid in something called the MEC reagent. This can identify alkaloids in spot tests. It consists of selenous acid and concentrated sulfuric acid. The concentrated sulfuric acid often rearranges the structure of the alkaloid, for example, turning morphine into apomorphine. The selenous acid then oxidizes these new structures into colored compounds called orthoquinones. Gloves are actually pretty useless when working with bromine. This needs to be safely opened. Bromine, even though it's quite a large molecule compared to air, it has a high vapor pressure. It will escape almost any container. It will form a dense gas inside any container and find its way out through any small gaps. Chemists like to use ampules to contain this unless they have Teflon sealed bottles. However, these are not cheap, as you can see. Don't breathe the bromine. Bromine's evaporating because it's warm, but it's also reacting. Still very acidic. The colour has disappeared. I should hopefully neutralize the hydrogen bromide. You have to check the pH. Still very acidic. Still acidic. Getting there. Just a little bit longer, I think. It's getting very close now. Now, it is looking a little bit acidic still. It's like 4, I think. It's not quite 3, so, well, it's getting darker as I hold it. Okay, a little bit more. Now, it is alkaline, slightly on the green side. And this is good. Next I can add barium chloride, which should precipitate out barium selenate. So that was fun. Here's my aloe vera. 45 grams of barium chloride. Barium chloride, a little bit cloudy. I might filter it. Okay, that's as clear as I can get it. All I need to do is add this to this. Am I ready? Yes, I'll do it. And there's our precipitate. Very nice. And now to filter this. This is to be filtered through this. This is taking a long time. I'll just leave it in the sun to dry out a bit. Look, barium selenate. Trying to get this in the sun, but the sun's disappeared behind that cloud. Here is the barium selenate, to which I'm going to add sulfuric acid. I'm just heating it up now to hopefully, I don't know, if it's going to help this to dissolve. Here I'm going to dilute some sulfuric acid because this is a bit too concentrated. Therefore, yeah, it really heats up contact with water. Now we'll add this to our barium selenate. Something going on. And since I don't have a centrifuge, I'm going to have to leave this standing for probably like a day. So
Barium sulfate forms as a white, highly insoluble solid that settles out of the solution. Solution: selenic acid remains in the liquid phase. Reaction type: this is a double displacement, metathesis, reaction driven by the extreme insolubility of barium sulfate compared to barium selenate.
Selenium has been used in red traffic lights. Speaking of traffic lights, this is the traffic light reaction. No sunshine.
Yes, lots of sunshine.